So this is a demo for lab 3. So initially we have the JIC loaded onto the board. So now I'm gonna turn on switch 9 and I'm gonna turn on the device. So as soon as I turn on, you see that the data is copied from the flash chip to the DRAM. So I'm gonna turn off the switch. So since I turned off the switch after the first initialization, it's gonna copy the contents again. So now I'm gonna press a reset. So you see our names are printed out. So I'm Gagan and my partner is Azaan. So initially we know that the DRAM should have these values, like in those addresses. So let's check the contents of the DRAM using the dump command. So dump, and we'll check from 080000. So we see that 080000FF has the value 0C. So if we scroll up slowly, we see that like the flash chip wrote 0x0C to that address, and that address has 0C correctly loaded. To further check, since these addresses are like very long, like the difference between the addresses, we can probably check 08000064FE, for example. So now I'm going to press enter, or sorry, I'm going to press reset, and I forgot what the address is. So it's 080064FF, and the starting address is FE because we're just checking from that address. So 064FF, 064FE. So now you see this is FE and this is FF, and that's 01, and that aligns with what data we're writing, 01 to FF location. So now we have verified that whatever the flash chip is writing to the DRAM is correct data. So now let's reset, and now we're going to program whatever's on the DRAM to the flash chip with the P command. So it's going to take a few seconds because it's writing 256 kilobytes of data. So now we see we're writing 0x0C from 800FF, and then so on. And like we're not printing every address because that will overwhelm, or like that will be like too many addresses printed out on the terminal. We're just printing a subset of addresses from in the 256 byte range. So now once we've written, we see that we display done writing. So now then after we wrote, we are reading back from the flash chip, and then we read back the same data that we wrote here, which is 0C, and we read 0C, 01, 01, 01C, 1C, and so on. And then at the end, we see that the data matches, and then we output a success. So that means whatever data we wrote, we are reading back the same data, and that's a success. So one more thing that was asked to do in the rubric was to load the hex file, or like to load the user program file. We can do that using the L command. So now we can send a text file. So to do that, I'm going to open file, send file, and I have the user program hex already compiled. Just have to load it. So this is a hex file. I'm going to open it. So you see over there it's being transferred. So now we see that it's a success. So we have downloaded about like 7K bytes of the hex file into DRAM. So now we're going to check the contents of the DRAM since we have modified it with the user program. So D, and then we see 0T000, and then we see it's different from what was there before in the DRAM. If you scroll up, we see the DRAM had different addresses. For example, it started at CF. Now it's at 46FC and so on. So now let's verify this again using the P command. So we're writing whatever is in the DRAM to the chip. Since our starting address for the printouts on the terminal is FF, we're going to print out 0A once we press P. So let's see if that happens. So I pressed P. So it takes a couple of seconds because it's 256 kilobytes of data. So yeah, as we expected, we're writing 0x0a, which is that FF location, to the chip. So now once that's done, we're again reading from the flash chip, and we see that the data aligns with whatever we wrote. So that's good, and the data also matches, and we output a success. So one more case that was asked to test in the lab handout was to like reset the device, power off the device, and remove the VCC. So in this scenario, we should see that no data should be written. So we're turning on switch 9, so it boots from the chip to DRAM. So now once I press the button, power button, we see it just stops at the first location. So we're not writing anything technically from the flash chip, because we disconnected the VCC. So now let's reset the device, reset it, plug back the 3.3 volts power supply, turn on the device with switch 9 on, and now we see the flash chip is writing data to the DRAM. And this is the user program, so we can just turn off the switch 9 and just say reset. This user program was provided in lab 1, so we just loaded that user program, which was just asking us to input integers, and it changed the LCDs accordingly. So now we can, like, as one final check, we can again say P, and this should print out the, or sorry, this should write from the DRAM to the flash chip and then read back the values. So yeah, so we're writing values. Done writing. And now we're reading back the written values. And then at the end, it prints a success message. So that's it for the demo. Thank you for watching.